good morning, good afternoon, good evening. Thank you for joining us. We're going to talk about metadata today. I'm joined here with my good friend Gal Baldwin, who's located in Tel Aviv. Hello, Gal.
Hello. How are you doing, Paul?
I'm good. I'm Paul Briscoe. I'm in Toronto, Canada. And we're with Tag Video Systems. Gal is our Chief Product Officer and one of our two brains behind everything we do, and I'm Chief Architect of the company. So let's talk a little bit about metadata. In the course of this, if a question comes up, please type it into the chat box. We have the chat box being curated, and at the end we'll address the questions we receive. So metadata. What in the heck is metadata? Well, metadata, by definition, is data about some other kind of data. So in the case of television, metadata is something that describes an attribute of, let's say, the video and the audio, which are really the two primary components. So for some examples of what we consider metadata, let's talk about what we're all used to. Things like closed captioning or subtitles. There's a perfect example of metadata. It goes along with the content, it's consumed at the end, and it's of key importance. And actually on captions, maybe it's time to digress briefly because there is a small confusion. Are closed captions, are they metadata or are they essence? And this is where we can actually make a distinction because closed captioning is actually essence. It's audio for people who can't hear audio. So it's very important. It can't be lost. It's actually part of the value of the program. It's not just descriptive about the content somehow. But at the same time, we don't transport it in a visible way burned onto the picture. We transport it as metadata. So it is metadata, but it's essence disguised as metadata. Other things are pure metadata, things that describe how the picture should be handled or processed downstream. And we'll talk about some of those. Where does metadata live? Well, it lives everywhere. It starts at acquisition. It works its way all the way through production. And the purpose of metadata is to get downstream, to do things downstream. And ultimately, a lot of it is to get to the viewer, to control their television, to allow them to actually receive the programming that the metadata is enabling, be it high dynamic range or other things that require descriptive metadata. And then the most important thing we'd like to talk about in this presentation is how you monitor it and why. Because if this stuff is so important, if it's necessary to actually render the picture, render the sound, and deliver the content, it's important to monitor because you have to keep your metadata going just as much as the video or audio. And if you don't do that, something breaks. Historically, metadata goes back right to the beginning of television. And I mean, the very first TV show was a camera, a transmitter, a receiver, a TV set. It was that simple. And as soon as we started to composite, add a commercial, do something like that, where someone else had to take an action. So for example, in the studio, they were ready for the commercial, they'd count down, they'd point, somebody'd do a switch. A transparent, invisible method to communicate that was needed. So there was actually a little thing used, which is a little tiny white Q dot up in the upper right-hand corner of the screen that would flash on and off once per second just before a commercial insert. And the person master control would be watching the live show, see the Q dot, and they would know when they had to roll the tape on the commercial and switch to the commercial. Not really metadata, hardly automated metadata, but that was the beginning of sticking something into the video to convey it elsewhere to do some work. So from that, it's evolved. And it's now become things in analog. We put all this metadata on line 21 or in the vertical blanking. In SDI, we do the same thing. In 2110, we have a separate metadata channel, but the metadata is still present. And as we'll describe going down the presentation here, metadata lives throughout the path. So Gal, can you tell us a little bit more about metadata?
In practice, the classical definition is metadata is whatever which is not the essence, and the essence is the video content and the audio content, and all the rest is considered metadata. Now, this data is part of the flow which is pushed from acquisition to the end customer along all the distribution chain. So it is essential part of the flow. It is true that during the flow, as the flow goes between the different distribution blocks, it is transformed and changes. For example, classical is between the uncompressed realm to the compressed realm. The way you encapsulate the metadata is different. But in essence, the content itself is going all the way from end to end sometimes just change the format in which it is carried. Now, there are two typical elements when you describe metadata. There's essence metadata, which is basically the metadata which is carried along the video and the audio and describe it to some extent. And of course, additional metadata that indicates actions along the distribution chains. And there's transport metadata, which is describing the transportation of the content itself. For this webinar, we will emphasize on the essence metadata, and we'll leave for now the transport metadata. Now, if you look from above at the distribution chain, it's have the four main blocks. You have the acquisition and live production part, where you generate or receive the initial data. This content is then pushed on to the next functional block, which is cloud or MCR. And this is where still the content is in the uncompressed realm. Next block is the distribution chain, which is separate to two main blocks. First is classical distribution, epic transport, multicast, and the new kid in the block, the OTT distribution. Paul, can you elaborate on the contribution, acquisition, live production block?
Sure. I actually want to throw in two little things that you twigged in my mind before we go on, though. And one is we're not going to talk about transport metadata, and that's for a good reason. Historically, television had one transport. Again, it was that tower on a hill broadcasting to a TV set. And life was easy. And we didn't have to talk about metadata transport because it was just in the vertical interval of the video, and that was the end of metadata. Today, all these transports we talk about, I mean, you talked about OTT being one of the transports. Within OTT, there are many different subtle ways that they differ. And the way that metadata has expanded across these multiple transports is almost scary. And it's almost a topic for a different conversation on a different day. The other thing I just want to mention, and let's apologize up front to the broadcasters of the world, when we say distribution, we don't mean to leave you out. We all know that if you're a TV broadcaster, master control feeds your transmitter, it goes over the air, and of course your metadata goes over the air. And if you're using DVB or if you're using ATSC, that'll deliver the metadata to the viewer. So we're not going to concentrate on those paths. We actually want to talk about the newer and more different paths in metadata. So to the broadcasters out there, please don't think we're in any way disenfranchising you. You're exactly the same as streaming distribution. Master Control puts together the show, pushes it out, and you broadcast it with a lot of RF. So contribution, acquisition, and live production, the exciting part of television. This is where we put together television. This is where content is created, where content is acquired and assembled into a program. This is not where commercials are added. Commercialization of the content is a different thing. This is where the show is made. Now, this domain is an interesting and a very fun domain. It's also a scary domain. This is a control room full of people in real time yelling and screaming at each other. It's a director yelling directions at all the operators and at the camera operators. It's a vision mixer operator, the technical director, switching the sources, bringing up the keys, managing all of that. It's high pressure. It's real time. There is no rewind and fix. So everything has to work in this domain. This domain is all uncompressed. It started as analog video. It's evolved through SDI, and today we're in 2110, and to some degree 2022-6 SDI on IP. But it's full quality. It's high bandwidth, so the infrastructure is a very rigid and formal infrastructure. Although, to digress, if you go out into today's world of remote production, that's not necessarily the case so much. This is where we put the show together, and this is where metadata really begins. So for example, if we're acquiring in the field and we're going to be doing recording for post-production, which is the relaxed, non-real-time version of live production, we capture time code. If you have 5 cameras shooting, they all have to have the same time code, so when you switch between them in post-production, you can actually align up all the things you're working with. The high dynamic range and wide color gamut metadata, if you're shooting in HDR, producing in HDR, this metadata exists with some of these formats, and this metadata is now created along with the image and needs to be curated along with that image throughout the image path, originating in the live domain. There may be audio metadata depending upon the audio mode you're producing to. If you're producing to certain compressed multi-channel audio modes, there's associated metadata. Of course, captioning and subtitles, they begin here in live production, where some poor panicked operator or two frantically type the live dialogue that's coming off the floor into the caption streams. But these are very important. This is essence for the hearing impaired, right? We have other things that may originate here, like AFD for format management with SD. We may be inserting a ratings code here. We may be shooting a beauty pageant which has one ratings code, or we may be shooting a children's show which has a different ratings code, and only we know that. Now that may downstream, by the way, get modified in a certain broadcast region where the beauty pageant may be okay for little kids. In other regions, maybe not so much. So it may originate here or it may not. And then there's one other kind of metadata. We promised not to talk, Gal, about transport metadata, but in 2110 there is this thing called the SDP. SDP is transport metadata that also contains useful information about the essence. So it's important to mention only because it has a double role, as metadata transports do, as we'll discover throughout this. Gal, anything else you want to add about this domain?
So if you think about it, it's originated from SDI, where the metadata being pushed as an auxiliary data separate from the video and audio. Move next to 2112, which is just taking the same SDI and moving to IP. And now with the 2110-40, all the metadata that resides before in the auxiliary data of the SDI has been pushed as a separate stream that runs in parallel to the video and audio flows. It is, from monitoring perspective, it is important to remember that two approaches that resides in this world. One, you do monitoring. You check what gets lost when you change the content, and usually one step after. So usually it will mean that you do monitoring either on ingress or outgress on the content that's coming in or going out of the functional block. But there is another approach to monitoring, which is operational, which means you do the monitoring on the handoff points between the operational blocks, just because it's not the same team and they want to know that the content they receive or the content they're sending to the next team is okay, which is sometimes the same as changing the content, but there are cases where it's the same content goes between operational blocks, not changing, but you still might want to monitoring. Now, when you're talking about the acquisition live production block for monitoring, of course, you can monitoring all the data for existing classical. You want to check if the FD exists. You want to check if the HDR metadata exists, the time code you might want to display. But usually the approach is more visual. You want to see on screen indicators that those elements exist or not. Now then this whole block is wrapped together and is being pushed to the next operational block, which is the MCR and the playout. And I pass it on to you, Paul.
Sure. Yeah, and so just of course, before we leave this, I have a comment, as you might expect, and that is just to remind us that post-production uses all the same metadata that's used in live production. In live production, all that metadata is living in one place at one time. In post-production, we're going to acquire content externally, and we're going to bring that into a post-production suite, no longer using real video equipment and videotape, but instead in a computer environment. And so some incoming metadata will arrive. Timecode will arrive with the content. HDR metadata, for example, will arrive with the clips, but other metadata will be added in the post suite. So it's important to understand that live production encompasses everything from a control room full of people screaming and yelling doing a football or a soccer game to distributed remote production where the yelling and screaming is over intercoms and there's less of it because they have to work on their own more independently, to post-production where the real-time activities are deferred, but all the same metadata comes to bear, and the output of all of those things is a TV show, and all of these metadatas are required in all cases. So that's why monitoring of the metadata, regardless of your infrastructure type in production, is very, very necessary. And then we get to the important point here, which is master control. Master control, this is where, in the case of a broadcaster or a live content producer or a playout producer, this is where the content meets distribution. This is where it leaves our domain. So we have here now a situation where we have a facility that contains two things. Broadcasting requires playout of episodic productions. It requires insertion of commercials. It has long form and short form content, to categorize them into two buckets. So we have to play out this content in order to fill the broadcast day and intersperse it with live production that comes in from news and sports and other things. So in master control, we have a small switcher called a master control switcher. It used to be the heart of the TV station, which is why it's still called master control, but it really should be called egress control. And this is where the composition of that whole program, TV day or TV show, is put together. When I say TV show, I mean the whole programming day. So the commercials are integrated with the bumpers and the stings and the long-form content, the episodics, the soap operas, which are interspersed with your news and live programming. So master control is the switcher where an automation system, which runs all of the playbacks, also runs this switcher and opens up windows for the live production studio. So coming up to the top of the news, the end of the show happens coming off disc, a couple of commercials run, a bumper runs, and then a red light goes on in the studio to say, it's the top of the clock, you're on air. And at that point, the live studio is feeding the output. So that's what master control does. It aggregates everything into a continuous stream of television broadcasting. Here again, all the same metadata is in play. And that's essence metadata, and it's transport metadata that we promised we wouldn't talk about, but all of it has to be there. It has to follow the content as well. So when we're playing back a clip off the server, which is a TV show that has its own metadata, that has to be going out. When we switch to the studio, that metadata has to be going out. That metadata leaving that egress point in the studio out of master control, that has to be continuous and it has to be accurate. Otherwise, things break. Gal, talk a little more about the metadata we encounter here.
So when you're talking about the cloud and the MCR, first of all, you have all the metadata passed from the production, the time codes, the HDR, and the FD, of course. There are two new elements which are usually starting at the cloud MCR, which are the captioning, subtitling, and the SCSI messages, which are usually inserted at this stage. Now, it is important to remember that cloud, of course, could be uncompressed and compressed, and then sometimes in a compressed cloud, you will have subtitle insertion environment, which push this into the content already made files with the subtitling. Now, of course, from monitoring perspective, you can monitor the changes. For example, you can check the SCSI exists or disappeared. You can check if you have your captioning or subtitles or they're disappeared. Now for SCSI, you can do even furthermore. You can log the SCSI messages to actually compare them later on to the downstream, to the other SCSI messages you receive down the distribution chain and compare them in case you have any problem. Now, the cloud and the MCR is also the last place where the content is most cases in uncompressed. And this is the point where it's moved to the next domain, which is the distribution chain, which is the compressed realm. And it means that the content is transformed from one container to another container. So the whole metadata, while the content exists, it's changed its clothes. It's now wrapped in a new format. Basically, you should consider the encoder as the glue point between the uncompressed world and the compressed world. And next function block, compressed distribution. Classical distribution, we're talking about MPEG transport, which is a container that is containing both audio essence, video essence, and all the meta combined together in an holistic environment. Now, the moment we're talking about compressed, some of the data changes its behavior, but still the essences are the same. You still push the AFD, you still push usually the subtitles, the rating, and one of the elements that's usually found out as a new metadata format is encryption metadata that is added to the content in the beginning of the distribution chain. Now, SCSI, for example, is passed on from the uncompressed to the compressed realm, where it's usually in that place. The encoder is changed from SCSI 104 to SCSI 35. Now, it is important to remember that when you move from the compressed to the uncompressed to the compressed, you transform the way you package the metadata. Some of that becomes an essence by itself. For example, SCSI and captioning are usually passed as a separate bit in your epic transport. They start to become a separate essence, not related directly, immediately to the video and audio essences. Some of it are passed on with the video and audio essence in the codec container itself. Paul, I believe that it's very interesting to describe a little bit more the way it's restructured.
So yeah, you've touched on a couple of really good examples. SCSI 35 and SCSI 104 are very good examples of two different things that do essentially the same thing and forever have to be translated from one to the other. Actually, a second axis of that situation is consumption of metadata en route, because here we encounter the first place where metadata may get consumed en route. The example I'll give you is we have, let's say, AFD metadata. So we have programs upstream that, let me give you this very strange kind of old-fashioned example. AFD was invented for standard def and HD happy marriage. So let's say you have a large amount of SD content mixed with HD content in your playout channel, and you're broadcasting to an HD path. You may, as a system design, elect to use AFD at the encoder and convert everything to the proper HD aspect ratio prior to emission. Or you could transmit AFD down to the viewer's set and let it do the job. In the case that I mentioned first, the encoder would actually eat the AFD and not transmit AFD anymore, because it would do the conversion of the SD appropriately into the HD format by using the AFD, and then it would throw away the AFD. So some metadata gets consumed en route. Another one that gets consumed en route is SCSI messages. You pass a SCSI message out in distribution, somewhere down the path, that message is actually used before it gets to the viewer to take action, to do a switch, to insert a commercial, to do a splice, to raise up a logo. It may be passed further down, it may be modified and passed further down, it may be replicated and passed down multiple chains for use in subsequent further distribution, because don't forget, distribution is this never-ending set of branches.
Chain.
Yeah, multiple chains though, right? You might have multiple regions, multiple languages, different commercials for different, so this is where metadata starts to get interesting, where it begins to get used. It's fine to stick it all in and follow it along, but using it is where it gets interesting. Also interesting and important to mention, this is the last place where you can monitor metadata and do something meaningful about it. And I say it that way because if we don't monitor metadata here and you monitor it somewhere way down the distribution path, when something goes wrong with the metadata, you're far away from the metadata. It's coming from some production facility somewhere way upstream, and you notice the AFD is missing. So if you monitor it at the output of this encoder, this is the place where it's all aggregated together, it's all on one wire, so to speak, and monitoring it there means you have the best handle on fixing it because it's all getting aggregated at that point. If one piece of metadata goes missing downstream, that becomes a complicated problem because it's all inside the same transport. And the likelihood is, in fact, low that that would happen. So let's talk about the more interesting thing in life here. And I'm going to actually put the heat on Gal a little bit for some detail, but let's talk about over the top, because this is the real new kid on the block. We've come from an RF carrier carrying video and audio magically through the ether, to cable systems that deliver originally analog over cable and digital over cable. And today, everything's broken. We have OTT. What is OTT? What is the top that we're going over? Well, the top we're going over are the first two things I described. The legacy schedule-based streaming television distribution. That's the top that over the top is over. How it works is very different. Scary different, in fact. It's designed for computers and browsers, and it has evolved through that generation of technology. So it's based on some fundamentally simple things. It's not streamed in the same way we think of it. Instead, that stream is broken up into small chunks of some number of seconds each into files. So these little tiny files, when all assembled, would put back together that original show. But the methodology of OTT is to deliver these little files sequentially to the player one at a time, a video file, an audio file, and the player assembles these and plays them, and it plays out these little short clips, and it sits there praying it gets the next clip before it's finished playing the present clip. And this ongoing playing of these little clips is how OTT works. It's not a continuous stream. It's a virtualized, literally a packetized, if you want to look at them as packets, it's a virtualized way to transport the stream. It's also interesting from the point of view that one incoming feed of content is transcoded into multiple renditions. These renditions are quality renditions from full resolution to lower resolutions, because one key of OTT is that depending upon your connectivity, you can only accommodate a certain amount of full speed video at a certain resolution. So the system can figure out what you can receive and deliver to you the best content it can for your link, your own personal link to the internet, without delivering you a quality level that causes buffering, lost frames, and so on. The same metadata lives inside this whole thing, and the same metadata is required because, again, we got to use this metadata for various purposes, especially at the endpoint. So metadata takes on very different forms inside OTT. Gal, tell us about metadata in OTT a little bit more, will you?
Sure. I want a little bit to track back to the compressed one thing. It is interesting to mark out that when you push the data from the uncompressed to the compressed domain, some of the metadata is pushed out of band compared to the video and audio essence. For example, captioning is separated, SCADA is separated, but also when you're talking about the video metadata by itself, the video essence, a large portion of it is taken from via the auxiliary data of the SDI, let's call it, and pushed to the container of the video codec, which is what the part is called the SEI. And this data then is carried with the video all along the way. Now, I'm mentioning that because it's interesting when it comes to the OTT. Now, the OTT, you have two functional basic elements. You have the flow of data, and you have the manifest that describe what the available flows. Some of the metadata would go to the manifest. Some of the metadata will continue with the video as it was published from the MPEG transport, and will go all the way to the end customer with it. It is important to mention that when you talk about OTT, it's not completely standardized. So when OTT came to life with the HLS, it was just packed up, chunked up TS file. So basically all the metadata available in the TS file was just pushed to the end viewer. Of course, large portion of this metadata was just leftovers. Nobody used it, but it was still existing in the TS file, in the PIDs and with the data of the video itself. What we see in the OTT that there is a beginning to standardize, especially when it comes to Dash. So, for example, SCADA messages, which were pushed in the TS domain as kind of an essence by itself, when it's come to OTT, you will see them more and more often in the manifest file itself. Actually, they take the SCADA messages, which is binary format when you talk about TS, and they push them on as a textual format, as a JSON string structure, a one-to-one translation of the SCADA 35, and we see a movement to standardize it. So you can actually check if it exists and log it and compare it to the SCADA messages up your distribution chain. Another interesting example is HDR. When HDR is pushed from uncompressed to the compressed, it's pushed as part of encapsulated with the video essence as part of the SEI block of the video codec. So when it comes to OTT, all this information just carries on because it's with the video. Usually when you talk about OTT, of course, you transcode the content to multiple variants, but from metadata perspective, you usually just pass along the metadata as is without touching it. So the metadata goes all the way to the and viewer without changing. Although the one in the HDR example, the one that's interesting, that the color space, for example, and the HDR type is available in the metadata. And it's actually interesting that it's the same logic which is applied in the uncompressed. The color space and the HDR type are supplied in the SDP and not part of the HDR metadata flow itself. Another interesting element where it comes to metadata uniquely to the OTT domain is, of course, encryption. In TS, it's not even encryption. It's usually scrambling. It's weak. Let's call it. It's a weaker way of encryption. Now, when you go to OTT, the approach is more DRM related when you talk about encryption. So all the metadata that indicates the end device to how it opens the content is supplied as a metadata block in the manifest file, which indicates that the end player, where should he reach in order to pull down and receive the keys in order to open it. But generally, I would say the same elements in OTT, they try as much as they can to keep them aligned to the behavior in the TS, but of course, the necessities cause changes, and large portion of it moves to the container, which is the manifest file. And if you think about it from above, most of the metadata supplied in the TS outside of the essence is transformed to the manifest, and what metadata goes with the metadata, with the essence, is pushed along without changing. Now, and of course, the last element, which is a little bit different here, is the fact that in OTT, the captioning becomes an essence by itself. It's a different stream by itself.
So, you raise a very interesting problem there, and I guess we're the right people to talk about it, because this makes your monitoring especially critical, doesn't it? If you have metadata not only occupying different formats, but occupying different transports, that makes it a very complicated thing to monitor from one end of the chain to the other. So clearly your monitoring system needs to be able to accommodate metadata in any form, in any transport, and also correlate to ensure continuity of that metadata through the system. So in OTT, this really, really obviously becomes a fairly challenging problem, doesn't it? So let's look at one more thing. And we don't normally think about this in television systems, but I'd like to consider this because this is the most important part of television. Why do we make all this metadata? It's for the viewer. At the end of the day, somebody is sitting at home watching TV or sitting nowadays watching it on something. So what does this metadata do? Well, ultimately, most of this metadata we get to the home. Some of it's used en route. We may use the HDR data to pre-render everything to one HDR format. So a mix of HDRs coming in, but at distribution we say, fine, we're distributing PQ today. So here's the PQ, here's the metadata, and we convert anything coming into PQ. We may do that with SCSI messages. They go downstream, they do stuff. But let's talk about what happens at the home. So you're sitting at your TV set or in front of your tablet or your phone. What happens? Well, this stuff comes in. What metadata is still there? Well, the necessary metadata is there, right? If you're running multiple formats, the AFD metadata has to be there to tell your TV set or your viewing device how to format that picture on a frame-by-frame basis. If you want to look at captions, that caption data has to be there so that the receiving and display device can insert that and overlay it over the picture. If there's ratings codes, these are key importance. These are law in some places. So if there's a rating attached to the show, that has to remain attached to that broadcast by law, just like caption by law in many jurisdictions, so that if a child is watching the show and we put on that topless beauty pageant or whatever inappropriate content, the TV set will not allow it to be displayed. So this metadata has two purposes. One is to curate the content as it moves through these production and distribution systems. And today, so many distribution systems, and frankly, distribution systems that don't use a lot of formally ratified standards, which makes life interesting. But it also takes care of what actually happens at the end. It actually drives the content, rendering the content consumption. And that's the whole point of metadata. And that's why it's important. Not just because, you could get a fine for letting a little kid see a beauty pageant or something like that. It's because you want to deliver the highest value, highest quality content all day, every second, minute, and frame, right? And the metadata is today unavoidable as something necessary to do that. So I think that's from one end of the system to the other, Gal. We've kind of dabbled with and talked about some metadata. And I think we probably have some questions in the chat box. If you have a question that's come up and you haven't typed it in yet, please do. And our helpers are going to help us with these questions. And we'll see what we can do. This is the freeform part of the show. How is metadata handled in a frame synchronizer? Ooh, I'll take this one. It's an SDI-ish kind of question anyway. It's poorly is my answer. Frame synchronizers do two things. They drop or repeat frames. If we have a chunk of metadata associated with every frame, let's say an AFD, let's say a caption, the frame synchronizer doesn't actually know what to do. It's not like you can interpolate metadata like you might be able to do with video to reframe rate it or something like that. So frame synchronizers do two very ugly things. They repeat the metadata when they repeat a frame, or they drop the metadata when they drop a frame. And if somebody knows a solution to this where you can actually do something useful with the metadata in a frame sync, please let us know. What's the benefit of separating the metadata from the video and audio in 2110? 2110. Everybody wants to know why we went ahead and broke down all the streams. Well, it's more than just not sending video to the audio room so you can demultiplex the audio from the video. Imagine we're producing a program in English, and we have an English caption track. And I'm distributing that show to 5 regions with 5 different languages. I can take that -40 stream and send it off to an IP service somewhere in the network that takes that caption stream and sends me back 5 caption streams, the original one plus 4 new language translations. I can also send it off to a language service that sends me back audio tracks over 2110-30, reading the captions. I can also send my 2110-30 audio track alone to a service that sends me back captions, actual caption text. So the beauty is we break down these independent elements of essence and metadata so they can be used in a very atomic way. I can take that piece of caption metadata and I can send it off to do something to it without having to send everything out and bring everything back and take it apart, put it together. What about standard definition in analog VBI metadata? Oh my goodness. So the analog VBI, it started with the Q dot and then moved up into the VBI, and then we added all these different metadatas as analog waveforms. Now in analog video, these are actually analog waveforms. In fact, for those who remember the HD transition from SD, thanks to a couple of vendors' ambiguity of choice of the start line of video, there's hundreds of thousands of hours of upconverted HDTV content today that has a white blinky line across the top because line 21 closed captioning from analog did not get blanked in the conversion to HD. So these analog waveforms in analog video, in legacy video, have to somehow be transported. And what we do today is we do one of two things. We transcode them, that is, we decode them and turn them into something new. So line 21 captions from standard def, we convert those into 608 digital captions in the SDI world. We do have in front of SMPTE a standard under development. It's actually recommended practice for direct carriage of SD over 2110. Actually, not that many people realize 2110 doesn't support standard definition video. Reason being, nobody asked. And actually, several years after it's released, people ask a little, so we're doing that now. And the question is, how do we want to handle this? And the decision is to actually handle it as video. So the VBI lines of analog waveform from the good old days will be transported across 2110 and reproduced at the other end verbatim as they were actually received in the system. We could make a standard that says you must, by mandatory rule, translate every one of them into a digital standard when you're coming from analog to digital, but that's onerous, and the market for translation from SD to HD is smaller over time. So we don't handle it very well. We handle it basically by encapsulation and transport, and when you need to use it, you decode it into a digital form, and you keep it there forever over -40.
It's actually interesting when you're talking about moving the captioning information from uncompressed to the compressed one. You would see more than one way to do that. Of course, one option is to take this captioning and push it on as subtitles, DVB subtitles. Usually it's more cloud scenario where you pre-prepare the content. And another method is that you would see is the OP47, which is one of the starter to carry the captioning information in the uncompressed realm. When it's transformed to compressed, you do see scenarios where they move it on as teletext subtitles. They just push it as encapsulated as teletext in the MPEG transport. And of course, the last option that you see is more, I would say it's more commonly used in North America, where you will take this captioning information, the 608 or the 708, and push them on as a metadata aligned to the video essence in the SCI. So in nature, it's almost mimicking the same behavior and of carry on the metadata in parallel to the video in very similar format.
You know, choice is a wonderful thing, but in technical standards and technical implementations, choice can be a bad thing. And this is why metadata gives people a lot of headaches, right? Is because it can exist in many forms and many renderings, and you got to get between them and handle them. And there's a lot of Swiss. Yeah, well, that's why the Swiss Army knife on my background, I guess, is because it just reminds people that metadata actually takes a number of different blades to handle. Another question. Where do you monitor OTT metadata? Oh my God, I'd simplify and say everywhere. Do you want to answer this, or do you want me to?
I would say first of all, if you have, of course, it's a question of access, but the region server, it's usually is the last place where you might change the metadata. So it's the place where you know that you would like to check that it's actually available and exists. But please remember, when you monitor for metadata in OTT, take into account there is a lot of leftover metadata that was just carried on through the distribution and is not actually used in the OTT. And you do see scenarios where the metadata in OTT is just not correlated to the actual data just because it's not common to use it. For example, video resolution. That could be passed in the manifest, but theoretically you could have some FD information still resides as part of your metadata. And of course, when it comes to ad insertion, especially when you're talking about digital ad insertion, you still might have a SCSI markers in the origin because the ad insertion is done afterward and the manifest is generated per region or per customer, and then you might want to look at on the metadata. Depends, of course, if you want to look at the metadata which is relevant for the experience of the end customer or for the ad insertion platform. So either before and after, depends on what you are trying to catch on.
Yeah, and going forward, of course, that'll even get more interesting because we're moving rapidly towards the point where your set-top box will insert the commercial it wants to show you. And upstairs, it'll insert a commercial it wants to show your wife. So those insertion messages eventually are going to end up being consumed in the set. So yeah, it's interesting. The other thing you mentioned, origin server, you may as well, if that origin server is feeding, 3 edges, you may want to actually monitor every rendition on every edge to ensure your SLAs are not being violated, and the whole idea is trying to get ahead of the phone ringing in your distribution center, right? So yeah. The more you can monitor, the more you can correlate, the better you can keep a handle on your system. One thing, I wanted to ask you about, you talked about modification of metadata in the system and so on. Is it useful to do comparison throughout the system in a templating manner where you say, okay, here's what it should look like, and then throughout the system I keep using that template as a way to validate a large amount of data that it's complete and it's all there and so on?
It depends on your flow, because there are a lot of elements, for example, that are just not changing along your chain. So monitoring them in the last point where you actually touch the content and change it would be suffice, because, for example, there are in many cases no point of monitoring the metadata of the video more than one place post the encoder, because nobody touch it. The video essence can disappear, but the metadata actually not changing. So it's depends on the structure of your network. And
sure. And the network nature of your streams and where the metadata is and all of that.
Yeah. or
Got
the
it.
insertion de facto.
So, we've talked here for 50 minutes and we've barely scratched the surface. We haven't talked deeply about any piece of metadata. It's a complicated, big, ugly world, and anybody who uses it will tell you those exact same words, complicated and ugly. But it's a necessary part of life, and we have over the years wrapped our brains around it. And of course, as soon as we do, we escalate it. Now with OTT, it just gets more complicated. But it's really important to monitor. It's important to us because, of course, that's the nature of our business. And so I'm glad we had the chance to share some of this info, and maybe we come back and do a little more depth on a couple of aspects of it at some point in the future. But with that, I think it's time to give people back a little bit of their days. I'd like to thank everybody for attending. Monitoring, we think, is an important thing, and we hope you do too. And we'd like to invite you to check out what we do. If you'd like to play with a tag system, we can get you dialed in and hooked up in no time whatsoever with a cloud-based instance, and you can play with and learn about and understand monitoring metadata, Essence, and all the other cool things you can do. So please feel free to contact us through the links you've seen in the chat box, or just tagvs.com. Happy to help you out. As well, any questions you have about metadata, throw them at us. We would love to help you out with your technical system issues. We're all learning. Forget about COVID. We're still all learning technologically. COVID just forces us to do that quickly. And if you've asked a question that hasn't been answered, and I'm quite sure there are many because I only answered a few, all questions submitted will be answered, and we will be providing that written question and answer response to all attendees. And with that, Gal, thank you for doing this with me.
Thank you, Paul.
I will say, the one nice thing about TV studios and real production is the colorimetry can be fixed. So I look like my liver is about to fail, and you look like you're running a very high fever, but neither is true. We're both the average of the color between us. Someday they'll put color controls on Zoom. Thanks to everybody.
Thank you.
Thanks to our team, Fallon and Cindy and Dana. We appreciate you guys and the work you do in the background, and Gali, of course. And until next time, thank you all very much for attending.
Thank you.